Okay, in this video I'm going to talk a little bit about solving radical equations. So you might be wondering what a radical equation is, and obviously it's just an equation with a radical in it. So it could be a square root, for example, this is a radical equation, not a very complicated one, but still. It could be a cube root, it could really be any root. There could be multiple roots, then it gets fairly complicated. But basically it's just an equation that has a radical in it. So we're going to learn about them by doing examples. So the first example is radical x equals 4. Generally speaking, what you do is you try to isolate the radical, get it by itself, and then you undo whatever the radical is. So this is a square root, so to undo a square root, I'm going to square both sides. So I have radical x squared equals 4 squared. And simplify that. X equals 16. So what I want to do is I want to check, but this one's easy enough that if you just think about it, it must work. So what I'll do instead is I'm going to draw a little picture. So I'm going to graph both sides of the equation. So I'm going to graph radical x, which looks pretty much like that. I'm going to graph y equals 4, which looks like that. And then, so that intersection point right there must occur when x is 16. So we get the point 16, 4. And checking is always a really good idea on these. Some of them are so simple that checking seems a little ridiculous. This is maybe an example like that. Let's try another one. So we have the cube root of x minus 8 equals 0. So the first thing I want to do is get the radical type thing on its own. So I'm going to add 8 to both sides and get the cube root of x equals 8. And now undo a cube root by cubing. So I'm going to cube both sides. So I get that, and then I get x equals 512. I had to think about that one for a little bit. So to check this one graphically, depends on if you know what the cube root of x looks like. So I do. It looks basically like x cubed just on its side. And then y equals 8 would be here. So what I'm seeing here is that it makes sense that I would get a solution. Because those two graphs should definitely intersect, so it looks like that's 512, and this ordered pair is 512, 8. You definitely maybe want to use a calculator to check that one. Let's do another one. So I have radical a minus 5 equals negative 2. So I'm going to do what I usually do. It's square root, so I'm going to square both sides. And I get a minus 5 equals 4. I'm going to add 5, so I get a equals 9. But maybe it doesn't, so let's check. So graphically, the square root of, I'm going to graph x minus 5, looks like this, where the x-intercept is 5 there. And then graphically y equals negative 2 looks like this. And you can see that those two graphs clearly do not intersect. So there actually should not be a solution. So let's check that kind of algebraically or arithmetically, I guess. So what I'm going to do is take the original and I'm going to substitute in my value. So I got 9, so I have radical 9 minus 5 equals negative 2, which is radical 4 equals negative 2, but square root of 4 is 2. 2 does not equal negative 2. So there are actually no solutions to this. So we got a solution when we algebraically manipulated everything, but it didn't work out in the original. There's a name for that, and it actually happens fairly regularly with these. And it's called an extraneous solution. So an extraneous solution is a solution that shows up when you algebraically manipulate. So you square both sides or cube both sides, whatever. You get answers, multiple answers, one answer, whatever. But then when you go back and check, it's not going to check in the original. So the key thing here, the absolutely most important part is check. You have to go back and check your answers. So let's do another one. So I have x plus 4 equals radical x plus 10. So it's square root, so I'm going to square both sides. Really common mistake in squaring x plus 4 is to forget that there's a middle term. So I'm going to actually get x squared plus 8x plus 16. Don't forget that middle term. Like this, move everything to one side. So far so good. Factor. That one's kind of easy to factor because the leading coefficient is 1. So either x equals negative 6 or x equals negative 1 should be solutions to this. But as we just saw, we really need to check them. So let's do that. So the first thing we're going to do is check x equals negative 6. So we go back to the original, we plug in. It gives me negative 2 is equal to square root of 4. And that I already know is a problem because negative 2 does not equal 2. Therefore, we can say for sure that negative 6 is not a solution. So that's definitely extraneous. Let's check the other one. So it could be right now that x equals negative 1 is the only solution, or maybe there are no solutions at all to this equation. So we're going to check x equals negative 1 in the same way. So plug in. And this one's already looking better. 3 equals the square root of 9. Square root of 9 is 3, so that checks. Therefore, we can say for sure that x equals negative 1 is a solution. So I like to go back to the original, cross out the one that doesn't work, and box the one that does. So that's basically how you solve radical equations. They take some practice, and you really just have to remember to check your answers because extraneous solutions will screw you up. I hope you found this helpful, and good luck.